So the idea is to engineer an ambidextrous arm where, because the arm is double jointed, we can bend the fingers one way, for example, to have a left hand, or the fingers can bend completely the other way for a right hand. It will also have wrist rotation, and this will be actuated pneumatically by airflow muscles, rubber muscles. So these pneumatic rubber muscles, when you inflate them with 3 or 4 psi of pressure, the rubber muscle expands in girth and contracts in length, producing a pulling force. 4 muscles are required to effectively control one finger. The middle and distal phalanges are driven by 2 antagonistic muscles, and the proximal phalange is controlled separately by a second pair of muscles. A PID controller uses data from angular and force sensors to appropriately inflate the muscles. A 3D model has been completed by Scientific Humanities to demonstrate the double-jointed articulation of the ambidextrous arm. By clicking the joints and by using the keys, up and down keys, we can demonstrate the movement of the arm. So there's also wrist flexion, and we can better see the thumb rotation here. New configuration of the fingers in their double jointed positions. Valentin Burov from Scientific Humanities has also implemented an augmented reality model of the ambidextrous arm, which can be actuated from the iPhone. The image that I'm holding is recognized by the camera on the iPhone, and the augmented reality arm pops up. The arm can be repositioned if I move the image, and also 4 buttons along the side of the iPhone screen allow actuation of the ambidextrous arm. So finger flexion, for example, can be actuated, wrist flexion, elbow rotation, and thus a performative choreography can occur between the virtual model and the physical body.
Just like a painter's medium is the canvas, the medium of a augmented reality designer is the interface. Create the best possible communication between a human and a computer. So for the Ambidextrous Arm project, we had to find a method in which how can we show an interaction of non-natural ambidextrous movements using human communication. So natural movements can be duplicated, but it cannot be changed, it cannot be modified on something that our joints cannot naturally do. So the method we settled on was a mobile interface in which people could see the virtual arm appear as a mechanical and tangible object in augmented reality using markers. The computer in this regard of the augmented reality is the one that we carry around in our pockets. And it is mostly run by this program here. There are a few scripts and some buttons which are placed upon the screen, another script for running the GUI which detects touch positions, and for the most part that is that, including a plugin that also detects the motion tracking. And in this case it is quite feasible to see a result of what tangible components will actually look like with a virtual representation of tangible parts.
In its physical form, the ambidextrous arm could be a remotely located platform for multi-user access, enabling therapy, for example, for amputees, and as an augmented reality object, it might enable phantom limb pain management.